Hello, welcome to Coding with Indy. In this video, I'm going to show you how to create a line chart showing progress over days using Flutter Canvas. I'm going to start from scratch and walk you through the whole process. No need to have any third-party libraries. It is quite easy, so follow along. So let's create a new Flutter project by typing Flutter create into the command line. And once the project is created, jump into the project folder and run .convert. This gives null safety. Null safety makes your apps more robust by removing spurious nulls in your app. The compiler is able to check the code and tell you at compile time where your code needs corrections so it won't crash at runtime. Let's open the main Dart file and clean up things. So now we have a basic home page widget, and in the body we will just put a placeholder container. We can set a color here so that we see the widget area, but that's optional. We can now go ahead and set the sized box as the child, and inside that we will create our chart widget. With the sized box, we can size our widget as we want. Now we're going to define progress chart widget. For that, I will create a new file and add a stateful widget called progress chart. And then we sort out the imports and wire things up. In the progress chart build method, we will set the CustomPainter as shown here. Don't forget to add the container as the child of the CustomPainter so that the correct widget size is passed into the canvas paint method. Now we're going to define the chart painter. This is a class derived from CustomPainter, and it implements two methods. For the moment, let's draw a circle on the canvas so that we can check if we wired things up correctly. Okay, great. Everything seems to be wired and we can see the circle in the middle of the chart widget. Now we're going to define a class called score. This class will contain the score values and the dates. A list of scores will be passed into the progress chart widget, and its job is to draw them pretty on the canvas. We prefix the member variables with the late keyword. Before null safety in Dart, anything can be null. With null safety, that is restricted. For example, a double can't be null unless you want it to be. Then you'll have to define a nullable double with a question mark at the end of the variable name. By using late keyword, we are telling the compiler we will set a value to these variables as soon as possible. And that's what we do in the constructor. So the progress chart widget will receive a list of scores. We jump back to the main.file file and fix the build method. And also we need to define a list of scores. We can generate some random values in the init state. So here we create some random numbers between 0 and 30. We're gonna generate 7 data values to simulate some data we retrieve from database of some kind. Now that we have some data, before we draw anything, we need to process the data into something that we can draw. We do that in the progress chart state class. We need to find the min max of the y values. So we can do that in the init state here. And then we want to have y and x values in 2 different arrays. Because y values will be double, a floating point number, x values will be strings shown as date labels. So the x labels need a bit of work. We want to show the short weekday and below that the day of the month. We can define an array of short weekday names like this and use it in our conversion function. Now let's see if we can see these data points on the canvas. Now before that, let's paint the background of the canvas with black like this. As you can see, it paints the whole screen. So to prevent that, we want to set a clip right. This will clip all the painting operations outside the bounds of the widget. We can do it like this. Now that we have done that, let's get into drawing. So the first thing to do is to compute some variables. We want to have some border around the chart we are drawing, because if we draw right at the edge, that looks nasty. Drawable height, drawable width defines the area we will actually draw. And we will divide the drawable height into 5 blocks. This is to give us some kind of a grid to place our drawing sections. The HD defines the block size by height. Similarly, WD defines the horizontal block size. Let's go and fix the constructor so that we can access the passed in values. Okay, now these two variables, height and width, define the rectangle where we will draw the points and lines. Its height is 3 times the block height. Width is all of the drawable width. So here it is a good idea to set some escape conditions if the values we compute are unreasonably small. The HR value we compute here will come in handy when we want to convert the data values to pixel heights. Height divided by range gives us that ratio. Now that we have these, let's set the left and the top of the drawable rectangle. Now we're gonna draw some rectangles that represents the bounding box of a data point. For that we need to define a center point so we can generate a rectangle. We will do the drawing in a small function called drawOutline. Let's go and define it. For each data point, that is y value, we create a rectangle and draw it like this. Mind you, this is to show us an outline where things would be. We're not drawing the data points yet. There you go. Now we can see the grid and our data points will be drawn inside these boxes. The space below will be used to draw the x-axis labels. Before we can draw the dots and lines for the data points, we need to compute these points. We do that in a small function called compute points. We iterate through each of the data point and get to the value and convert to a pixel height. We need to invert as our y-axis is going downwards, but we want to see the chart y where the values go up. So this produces a list of points we can draw dots with. So this is how it looks like. It seems we have the points drawn properly, but we need to create a path so we can draw the connecting lines. The compute path function will create a path object from this list of points, and it looks like this. We should move to the first point and then draw lines to other points. So the line connecting the data points will look like this. But it is not there yet. We want to draw dots at each point over the lines. Let's loop and draw circles like this. So this needs a bit of work. We want a black circle with a white border on top of the lines. We can do that by first drawing a filled circle first and then a border over it. Alright, that's more like it. We are definitely getting there. Now we want to put data labels next to the dots. For that we create a function called compute labels. So in that we convert our data values into a string with 1 decimal point. Now we will draw the labels. We can draw the labels in the same loop. For this we need a function called draw text centered. If you have seen my previous videos where I draw text on canvas, this should be familiar. But if not, just go with it. It just draws text on the screen given a few parameters. So before we draw anything on the screen, text has to be measured. That can be done in a function called measure text. It creates a span with the text and the style, and then create a text painter. And text painter lays out the text inside a given width. Once we have this, we can compute where to place the text and then draw it. Aha! So I made a mistake. Everything is drawn on top of each other. That is because I didn't update the C variable. C gives the position to draw the text at. The text will be drawn centered around that point. So this loop is getting crowded. Perhaps it's best we separate out these operations. So a bit of refactoring here. We can create a function called draw data points, but it would be best if we have the label drawing in a separate function. So let's create a draw labels function and then clean up the draw points function. So labels are being drawn, but we want them to sit next to the dots. So for that, we need the points in draw label function, but that's a small addition. As you can see, we need a little offset for the data label from where the dot is drawn. Let's create a position called ly, derived from the data point position. So we're going to place the label above the dot, but also we want it not to go outside our drawable area. All right, we are definitely getting there. Now we're going to draw X labels. These will be below the boxes we already have. Let's create a function for that and then loop over the labels and draw text. It needs a few params and a text style. We made a mistake. The center position we passed in is wrong. Let's fix that. We need to set that position at the bottom of the block. Okay, now that we have everything, we can remove the grid and it looks great. We can make it a bit more beautiful by setting some colors. Amazing, amazing. That looks excellent. Okay, so that's all there is to it. Thanks for watching. Hope you learned something and enjoyed this video. If you like what I create, please take a few seconds to like, share and subscribe to the channel. That would give me a good indication whether to continue making this type of videos. If you have questions, please leave a comment. I will do my best to answer. Until next time.